Hi guys, hope you all are doing well in life. So welcome to today's class. So it's 7:58. We will start after 2 minutes. So today's class is on number system, as you can see, and yeah, we will start within 2 minutes. So number systems, if you see, it is, a very fundamental topic, right? Whenever you're dealing with quants, you have to deal with numbers for sure. So it's a very fundamental topic, and we will learn this. What's it? 7:59. Yeah, it's 8. Let's start. So, welcome guys to the quant session of IIM Bangalore UG admission test. Today's topic is number system, a very fundamental topic, right? Every day in life we deal with numbers. In exams, we have to solve, questions of quants. So we have to deal with numbers. So, anyhow, number systems is something which we should know, right? I feel. Okay, so before starting, just a small intro about the IIM Bangalore's UG course, right? So IIM Bangalore, as you all know, has launched a new undergraduate program. So the program is basically a BSc honors in economics or a BSc honors in data science, right? So there are two courses basically, and we have also written the eligibility. So eligibility, as you can see, so it is based on your class 12, right? You have to pass your class 12 exam. You need to have maths as a compulsory subject, right? And also another thing is that in maths you have to score at least 60%, right? That is also another criteria. Okay, and obviously, to get admit, very obvious thing is that you have to qualify the test and you have to qualify the interview, right? So needless to say, this is after this. Now this was about the course. Now we will discuss about the test. So the test is a 2-hour test, computer based test, and which will have 60 MCQ, and the breakup is like 15 from English, right? 30 from quant and DI, right? 30, 15, and 15 from logical reasoning. So today we will deal with this section, quant and DI, right? The topic number system will come under this quant and DI, okay? And the marking scheme is +1 and -1/3. For correct it is +1, and for negative it is -1/3. Chalo. Next. Yeah, so also guys, Cracku has launched 5 free mocks for this IIM Bangalore undergraduate test. You can see here 5 free mocks Cracku has launched. So whoever, since a lot of you guys are watching, so please give this mocks, right? And all of these are free. By giving these mocks, you can get an idea of what kind of questions can come, right? You can simulate a test based thing in your home, right? So please, give these mocks. Now the way to reach these mocks, I will tell you. So basically, yeah, see, this is the main page of Cracku, right? When you will open Cracku, this is the main page. You go here. Here you can see there is written IP Maths and IIM Bangalore undergraduate. You click here. The last option you can see it is IIM Bangalore UG mock test free. You go on here and you can give 5 free mocks, completely free, right? Do take them, okay? And yeah, let's start the topic. Okay, so the first topic in numbers, we will deal with prime numbers. Now, what are prime numbers? Prime number means a number. So we are having a number which will be divisible only by that number itself and 1, right? So any number which is divisible only by that number and 1 is a prime number. Example is the first prime number in our number system is 2. If you see, 2 is divisible only by 2 and 1, right? There are no other number which can divide 2. Then I can say 3. Then comes 4. Now, is 4 a prime number? If you look at 4, 4 is divisible by 4. 4 is divisible by 1. But 4 is also divisible by 2. So since 4 is also divisible by 2, so this criteria is not being satisfied, right? The condition for prime number is that that number has to be divisible by 1 and that number only. There can't be any other number which divides this number, right? So here 2 is dividing 4, so we will reject 4. Then is 5, again 6. Now 6 is divisible by 6, it is divisible by 1, but 6 is also divisible by 2 and 3, right? 6 is also divisible by 2 and 3. Again, our main condition is not being satisfied, so 6 is not a prime number. Next prime number comes is, this is 5, this is 7, right? Like this if I write, so the prime numbers will be 2, 3, 5, 7, 11, 13, 17, 19, then comes 23, and like this it goes on, right? This is the prime number series. Usually it is recommended to keep in mind all the prime numbers up to 100, right? For example, I know all the prime numbers up to 100. So I will also, recommend you the same. Now the reason why are we discussing prime numbers is because from prime numbers we can make any number, right? I mean, this we will learn in our next slide. But for now, I hope you guys have understood the concept of prime number, right? Also, one more question is, now if 2, 3, 5, 7, these are prime numbers. If 2, 3, 5, 7, these are prime numbers, then what are 4 and 6, right? For example, numbers say 4, 6, 8, 9. What are these? What we call them? So the numbers which are not prime, we call them composite number. We call them composite number. Okay, so we call them composite number. So numbers which are not prime, that we call them composite number. Lastly, what about the number 1? The number 1 is neither a prime number nor a composite number, right? Keep this in mind. That numbers 2, 3, 5, 7, 11, 13, they are prime numbers. 4, 6, 8, 9, they are composite number, and 1 is neither prime nor composite. Okay. Let's move to the next slide. Now comes prime factorization of numbers, right? Now, as I was telling, that why did we learn prime numbers first? The reason we learned prime numbers because from these prime numbers we can make any number in our number system. Any number in our number system. I hope it is visible, right? We can make any number in our number system from these prime numbers, and that's why they are termed as prime. Prime means what? The essential thing, right? So these numbers are essential. For example, let's take the example of 4. 4 I can write as 2 square, right? 2 is a prime number. So if I say, if I multiply 2 with another 2, I will get 4. So I can make 4 from the prime number 2. Similarly, 6. 6 is 2 into 3, right? 6 is a number which can be made from two prime numbers. One is 2, another is 3. 2 3s are 6. Let's take another number. Let's take, for example, let's take 242. 242 is, guys, nothing but 2 into 121, right? And what is 121? This is, one second. Yeah, this is 2. This is 2 into 11 square, right? Which means 242, this number 242, I can say it is made from two prime numbers. One is 2 and another is 11, where 11 is being multiplied twice, right? It is basically 2 into 11 into 11, right, guys? So any number we can make from the prime numbers, and the breaking up of any number to its prime format, I mean the breaking up of any number in this format, that multiplication of prime numbers, this is what we call prime factorization of numbers. Means, let's erase this part. Yeah, is this. Let's say we have taken a number, say 960. We need to write 960 as a multiplication of prime numbers, right? That is our goal. Okay, so how to do this? The way of prime factorization is, you have to divide the number repeatedly by a prime number. For example, 960, I know 2 can divide this, right? 2 can divide 960 because 960 is an even number, right? And since it is an even number, so it is divisible by 2. If 2 is dividing 960, quotient will be 480. Again 2 can divide this, 240. Again 2 can divide this, 120. Again 2 will divide this, 60. Again 2 will divide this, 30. Again 2 will divide this, 15. Now 15 is an odd number. 15 won't be divisible by 2. After 2, what is the prime number we are having? We are having 3. Now can 3 divide 15? Yes. I am having 3. Quotient is 5. Now 5 itself is a prime number. So the number which will divide 5 is 5 only, and here we are getting 1. So we need to do this process until we reach this 1. So what is our main goal? Main goal is to divide the number repeatedly. Why this pen is not working good? Yeah, repeatedly by prime numbers until we reach 1. That is our main goal, that we have to divide this number repeatedly, we have to divide until and unless we are reaching 1. So 960, how we can write? So 960 I can write 2 multiplied 1, 2, 3, 4, 5, 6, 7, 6 times. 1, 2, 3, 4, 5, 6. So 2 multiplied 6 times means 2 to the power 6 multiplied by 3 and multiplied by 5. So this is how we are writing the number 960 in its prime factors format, right? What are 235? 235 we will tell as the prime factors. The term factors we will learn in detail in the further slides, but for now I am telling factors means, factor of a number means any number which can divide this number, right? That we call as factors. So the prime numbers which will divide any number is called the prime factors. For this case 960, the prime factors are 2, 3 and 5. And since they are prime factors, so I can tell that I can write 960 as a multiplication of 2, 3 and 5, right, in any format. In this case, the format is 2 to the power 6 multiplied by 3 multiplied by 5, right? So this is the main agenda, or the main thought about prime factorization of numbers. Okay, yeah, 814. Okay, let's take another example. Let us take now example of let me erase this. Okay, let's take example of, say, what can I take? I can take is, let's say example of, say, 441, right? 441. So 441 is an odd number. It is not divisible by 2. The prime number which can divide this is 3, right? Now how can I tell 3 so fast? Now this also we will learn in the further slides, right? That how to check which number divides what, right? But for now, let's learn this concept, how to do prime factorization, right? So 441 is divisible by 3 and the quotient will be 147. How are we getting this? We will simply divide 441 by 3. So this is 14, 42, 21, 7. 21 minus 1, 0. Okay, now we will divide by 3 again. So 147 by 3 is 49. 49 we can divide by 7. 7. Again, now 7 is a prime number. So 7 can be divisible by 7 only, and we are arrived at 1, right? So we have followed our process that divide the number repeatedly by prime numbers until we reach 1. So we have reached 1. So now our process ends. It's a stop. So what is 441? 441 is 3 into 3 into 7 into 7. So it is 3 square into 7 square. This is the meaning of 441. So first question is, what are the prime factors of 441? 3 and 7, right? Again, prime factors means what? Prime numbers which will divide our main number. So 441 is being divisible by 2 prime numbers. They are 3 and 7. And since it is divisible by 2 prime numbers, so I can write 441 in terms of prime numbers. I mean in terms of its prime factors, right? So 441 I can write in the format 3 square into 7 square. Okay. Let's move to the next slide. Yeah. Now comes divisibility check. As I was telling in the previous slide, that how to know a number will divide another number. I mean how to be fast. So that process we call as divisibility check. Means the conditions which has to be followed so that one number will divide the other number. And usually we do this divisibility check, we usually do this for prime numbers. The reason, as I have told, since we need to find the prime factors of a number. So since we have to find the prime factors of a number, we need to know which prime number divides another number under what condition, right? Let's understand. Divisibility by 2. So 2 is our first prime number. Divisibility by 2, the condition is that the last digit of any number, let's say we are having, say, a 5-digit number. For 2, we will only see the last digit. If this last digit is divisible by 2, now last digit divisible by 2 means the last digit can be either 0, 2, 4, 6 or 8, right? Can it be 10? No, because it's a digit. Digit means it has to be between 0 to 9. So between 0 to 9, the numbers which are divisible by 2, what are they? 0, 2, 4, 6, 8. So basically I can say that any number is divisible by 2 if the last digit is 0, 2, 4, 6, 8. Because if the last digit is 0, 2, 4, 6 or 8, then only I can say the last digit is divisible by 2. So last digit divisible by 2, in another way we can write that the last digit has to be either 0, 2, 4, 6 or 8. This is the condition, right, for divisibility test of 2, that the last digit has to be divisible by 2 or it has to be 0, 2, 4, 6 or 8, right? Now comes divisibility by 4. Now 4 is not a prime number, but still we can know the divisibility test by 4. The reason being, if you see, 4 is 2 square, right? 4 is nothing but 2 square. Again you can see 8. 8 is nothing but 2 cube, right? So these are basically powers of 2. So since we have known for 2, what will be for 4? Now 4 is 2 square. If you see, divisibility by 4 means, here what will happen? Here the thing is that last 2 digits have to be divisible by 4. So in this case, again if we take this example, say 1, 2, 3, 4, 5. We are having a 5-digit number. The divisibility test for 4 means the last 2 digits has to be divisible by 4. Means, suppose we are having one number where last 2 digits are 16 and another number where last 2 digits are 22. We know 16 is divisible by 4, which means this number will be divisible by 4. We know 22 is not divisible by 4, which means if the last 2 digits are 22, so that number won't be divisible by 4. Although you can see, guys, both these numbers will be divisible by 2, right? Because last digit is 6 and 2, both 2 and 6 are divisible by 2. So from here, what I can say is that if a number is divisible by 2, it is not necessary that that number will be divisible by 4. Our first inference. Second is what? For divisibility test of 4 means the last 2 digits has to be divisible by 4. This is the main condition. The last 2 digits, if it is divisible by 4, then we can say that number is divisible by 4. And why are we saying last 2 digits? Because 4 is nothing but 2 square. Since the power raised to 2 is 2, that's why we are telling last 2 digits. For example, in case of 8, if you see, the power is 3, which means for 8, what will be the condition? For 8, the condition will be last 3 digits. And yeah, it is written here that the last 3 digits has to be divisible by 8. Since 8 equals to 2 cube, so the last 3 digits has to be divisible by 8, right? So we are done with 2, 4 and 8. Now comes 6. Now guys, see, we know 6 is 2 into 3, which means I can say if any number is divisible by 6, listen carefully, if any number is divisible by 6, since 6 is 2 into 3, which means I can tell that number has to be divisible by 2, also has to be divisible by 3, right? 6 is nothing but 2 into 3. So if any number is divisible by 6, means that number has to be divisible by 2 and that number has to be divisible by 3. If both 2 and 3 are dividing that number, then only I can say that number will be divisible by 6. And this is only written here, that numbers which are divisible by both 2 and 3, they are divisible by 6. Okay. So we are done with this. Last, we are having divisibility test by 7. Divisibility test by 7. So basically, guys, this we are having one example in today's live class where I will teach you divisibility test of 7. There I will show, because it's a complicated process, to be honest, and we need an example. I mean, I am not getting any such number, but the best way is that we will deal with that question. For now, we can skip it, right? We will solve that question. I think it is question number 7. I think I don't remember. Okay, let's move to the next slide. Okay, we are having other prime numbers 3, 5 and 11 and another composite number 9. Now again, divisibility test by 3. So divisibility test for 3 is that the sum of digits has to be divisible by 3. Means any number, say we are having 1, 4, 2, 3, 5, 6. Let's say we are having this number. Sum of digits will be what? Sum of digits is nothing but you just sum up the digits. Means sum of digits, SOD, sum of digits is 1 plus 4 plus 2 plus 3 plus 5 plus 6. So sum of digits is what? 1 plus 4, 5, 5 plus 2, 7, 7 plus 3, 10, 10 plus 5, 15, 15 plus 6, 21. So if this sum of digits is divisible by 3, if the sum of digits is divisible by 3, means that number is divisible by 3. Means that number is divisible by 3, right? Similarly, if the sum of the digits is divisible by 9, for example, in this case, we are having sum of digits as 21. 21 is not divisible by 9, which means this number also won't be divisible by 9, right? Now, for example, if I have taken the number as 1, 4, 2, 3, 5, 6, 6. In this case, what will be the sum of digits? In this case, sum of digits will be 1 plus 4 plus 2, 3, 5, 6 plus 6. 5, 7, 10, 15, 21, 27. So in this case, the sum of digits is 27. 27 is divisible by 9, which means that number will be divisible by 9. 27 is divisible by 9, which means this number is divisible by 9. So, I mean, pretty simple. Again, I am telling that for 3 and 9, it is pretty simple. Whatever number is given, you just do the sum of the digits. If the sum of digits is divisible by 3, means that number is divisible by 3. If the sum of digits is divisible by 9, means that number is divisible by 9. For 5 what we are having? Now 5 is quite similar to 2. For 2 what we had? The last 2 digits has to be divisible by 2, right? I mean for 2 what we had? For 2 we had that the last digit of the number has to be divisible by 2, which means the last digit can be either 0, 2, 4, 6, 8. Same is the case for 5 also. For 5 also the last digit has to be divisible by 5, which means the last digit has to be either 0 or 5, right? And this you can infer. I mean, this is a very basic thing. We all know the table of 5, right? 5 ones are 5, 5 twos are 10, 5 threes are 15, 5 fours are 20. So you can see the last digit of any number which is divisible by 5. It is either having 0 or having 5, right? Very basic thing. Now comes divisibility test for 11. Oops, wait. Yeah. Now we are having divisibility test for 11. What does this mean? This means, suppose we are having a number. Okay, let's first read it. So it is given sum of odd digits minus sum of even digits should be 0 or divisible by 11. This is a statement, but let's try to understand. Let's say we are having a number 1331. Let's erase this. Okay, let's say we are having a number 1331. Now if you guys see, this is the first digit if you're counting from right to left, right? If I'm counting from my right hand side to left hand side, this is the first digit. 3, this is the second digit. This 3, this is the third digit. This 1, this is the fourth digit. Now, what is the meaning of sum of odd digits? Sum of odd digit means sum of the digits which are in the odd place. Sum of the digits which are in the odd place means here odd place is 1 and the first place is 1 is an odd number, right? 1 and 3 are odd numbers. So this is the first place, this is the third place. What is the sum of our digits? Sum of digits is 3 plus 1, which is 4. Similarly, sum of digits in second and fourth place, right? I mean even places, some of the even digits. Even digits are what? Which are in the second place and fourth place. So what is the sum of digits in this case? 1 plus 3 equals to 4. And what we have been told? We have been told sum of odd digits minus sum of even digits means 4 minus 4, which is nothing but 0, right? Since 4 minus 4 is 0, now if this difference between the numbers, or the the difference between the sum of digits in the odd place and the sum of digits in the even place, if that difference comes out to be 0, or it comes out to be a number which is divisible by 11, then I can say that number is divisible by 11. In our case 1331, the difference is coming as 0, which means 1331 is divisible by 11. Let's take another example. Wait, let me think about another example. Another example I can take as what I can take 11. 22, 484, 11 into 8. 1 second, guys. Let me think another example is. Okay, let us take this example. Let's take example of let's take this example 605, right? 605, if you see, guys, here we are having 3 digits. Again, counting from right to left, this will be the first digit, this will be the second digit, and this will be the third digit, right? Again, we'll follow the same process. Sum of digits in the odd places. What are the odd places? Odd places are 1 and 3. So sum of digits in the odd place are, it is 6 plus 5, which is equals to 11. And sum of digits in the even place. Now in even place, we are having only one digit. I mean, we are having only one digit which is in the even place, and that is 0. So what is the difference? Difference is 11 minus 0, which is 11. And what is the condition we have read? We have read that the condition states that this difference either has to be 0 or this has to be divisible by 11. So 11, we are getting the difference as 11, and 11 is divisible by 11, right? Which means I can tell this number 605 is divisible by 11, right? I hope you guys have understand the way to do the divisibility test. Remember, guys, each and every number divisibility test is important. It will help you to think fast. It will build your speed. Whenever you will see a number, you can get that feeling, yeah, this number will be divisible by this prime number. So understanding of this topic is very much important, not only for this entrance exam, but also, I mean, in future also, any, quant topic you deal with, right? So this topic is very much crucial. So if you guys did not understand now, please go and rewatch the video lecture, right? This video lecture will be available after the stream ends, right? So please go and rewatch this again and again, because this is a very crucial thing, this divisibility test, right? And also try to remember all of them, right? That for 2, what is the condition? For 3, what is the condition? For 5, what is the condition? For 11, what is the condition? Only condition I have not covered is of 7, that I will cover in one example, right? So let's move to the next slide. Okay, before this, so we are having 833. Fine. So before this, now since you guys all know that Cracku has launched IIM Bangalore UG program, live streams every day on YouTube. So this is the list of live streams we are having this week. The week is 26 October to 2nd November. I mean till this Sunday. So we have made up a list. This is actually today's session, right? Today's session is this, right? Of number systems. Guys, do take a screenshot of this, right? Every day we are live on YouTube, right? You can also see the timings in weekdays, that is from Monday to Friday. Our streaming time is from 8 p.m. to 9:30 p.m., right? That is our streaming time. And in weekends, that is Saturday and Sunday, we will be streaming at from 3 o'clock to 4:30 p.m., right? In the afternoon, right? So guys, please watch each and every lecture, right? All this is free from, Cracku site, right? YouTube, anyone can watch. So this is completely free from the side of Cracku. So join each and every lecture, right? Try to attend each and every classes so that you get a good score in the entrance test, right? We will cover all the topics starting from quant, DI, logical reasoning, verbal, everything will be covered. So yeah, do join every day. The timings I have shared. In weekdays, the timings are from 8 p.m. to 9:30 p.m. and in weekends, that is Saturday and Sunday, the timing will be from 3 p.m. to 4:30 p.m. So basically, each and every class will be of 1 hour 30 minutes. And don't take it that it is 90-minute class, it will be long, but each and every class will come with fun. We will solve a lot of problems. We will understand a lot of concepts, which will help all of you guys to clear this test, right? So please take a screenshot of this, right? I am going aside. Please take a screenshot of this to keep a note of the classes until Sunday. Okay, I think the screenshot is done. Okay. Let's move to the next part. Okay. Then we are having factors and multiples. Now, factors and multiples. As I have told previously, so factors mean, the meaning of factors is any number. Say if I am taking factors of number n, here is a number n. What is the meaning of factors? Factors means a number is, we can say a number as a factor of n means that number. I don't know what is happening in this pen. Okay, that number should divide n, or I can say in the opposite, that n should be divisible by that number, which means any number which divides n or any number through which n is divisible, we will call that number as factor of n. We will call that number as factor of n, right? Similarly, we are having multiples. What is the meaning of multiples? Multiple means any number which n can divide, right? Any number which this number n can divide. So it is the opposite basically. Any number let's move a bit up. Yeah. Any number which the number n can divide right? So that we'll call as multiple. For example, let's take the number 22. What are the factors of 22? Any number which will divide n, any number which will divide 22. What are the numbers? The numbers are 1, 2, 11 and 22. These are the numbers which will divide 22. So I will tell that the factors of 22 are 1 to 11 and 22. But what are the multiples? Multiple means the numbers which 22 will divide, which means what are the numbers? 22 into 1, 22. 22 2s is 44. 22 3s is 66. And the list goes on. Right? So basically this multiples is nothing but the multiplication table which we have learned in our childhood. Right? Multiplication table of 5, 6, 7. Right? So that means they are the multiples. For example, multiples of 5 will be 5, 10, 15, 20, 25, right? Important thing to note that factors of any number is always less than or equal to that number, right? Because what is a factor? Factor is a number which will divide that number n, right? Any number which will divide n. So obviously a number which is greater than n, it can't divide n, right? Very obvious thing. So the condition for factor is that it has to be less than or equal to n, right? Similarly, the condition for multiple is that number has to be greater than or equal to n. Same logic, if the number will be greater than n, then only there will be chances that that number gets divisible by n, right? Also one more thing, another thing is that you can see 22 is coming here also, 22 is coming here also, which means a number is always its own factor and also its own multiple. So another conclusion which we can tell is a number is always its own factor and multiple, right? Also you can see the number of multiples are infinite, right? I mean, whatever number we multiply with 22, we can multiply 22,000, 10,000, that we can call as a multiple of 22, right? So multiples of a number are infinite, but factors of a number are finite, right? We are having a fixed number of factors. So basically factors of a number we can count, they are finite, and multiples of a number are infinite. So another conclusion is, yeah, let me move this a little up. Another conclusion is factors of a number are finite, they are fixed, and the way to count them that we will learn in the next slide. And we know multiples of a number are infinite, right? Multiples of a number are infinite. Fine. So this is, we have learned about factors and multiples. Let's move to the next slide. So the next part is about HCF and LCM. HCF, the full form is for highest common factor. LCM stands for least common multiple, right? So basically it is related to the concept of factors and multiples, right? It is related to the concept of factors and multiples which we have learned in the previous slide. Just a modification. HCF is the highest common factor, LCM is the least common multiple. Let's understand this. So basically when we have to find HCF and LCM, means we have to deal with, more than one number, means we have to deal with two numbers, let's say 23, 69. We can deal with three numbers, let's say 60, 30, 20. So we will deal with more than one number. Then only we can say what will be the HCF of 23 and 69. What is the LCM of 23 and 69? Similarly, what is the HCF of 20, 30 and 60? What is the LCM of 20, 30 and 60, right? So this is what we have to find. Let's understand the process. Now, the main thing which we have to do is again prime factorization method. Our most basic thing is prime factorization method, and that will give us answer of all these things. If you guys see, let's take this example. 23 and 69. 23 is what? 23 is a prime number. So it is 1 into 23, right? 69 is a composite number and it is 3 into 23. Let's understand that definitions. Or 69 we can also write in this format, 1 into 69, right? Let's understand this definition. Highest common factor. What are the common factors between 23 and 69? What are the common factors between 23 and 69? What is the answer? 23 itself and 1, right? 1 will be a common factor for sure. Which means, now these are the common factors. What is the highest common factor? Means among these, what is the highest? The highest is 23. Which means from here I can tell that the HCF of 23 and 69 is 23. Right? Similarly, let's understand this. Least common multiple. So again, we are hearing the term common multiple. So what will be the multiples of 23? Again, multiples of 23, multiples are nothing, but we have to write the table. So 23 ones are 23, 23 twos are 46, 23 threes are 69, 23 fours are 92, 23 fives are 115, 23 sixes are 138, and like this the series goes on. Similarly, what are the common factors? What are the multiples of 69? 69 ones are 69, 69 twos are 138, 69 threes are 207. Like this the series goes on. Now what I am telling is that we have to find the common multiple. So what are the common multiples of 23 and 69? You see 69. You see 138. So the common multiples of 23 and 69 are 69. $138. It's not working. I think in top we can't write. Yeah, 69, 138. These are the common multiples. And we have to find what? We have to find the least common multiple, which means least among these numbers. What is the least? It is 69 itself. So basically, what will be the LCM? LCM is 69. Now this is the fundamental process which I have shown, but in exam conditions, we are having one more method. Let's learn one more method. The other method is basically, guys, we will do prime factorization of 23 and 69 simultaneously. Means we will write 23 here, we will write 69 here. Which number will divide both 23 and 69? Answer is 23. 23, when it is dividing 23, quotient is 1. 23 when it will divide 69, quotient is 3. We have prime factorized. What is HCF? HCF will be this. The number here will be HCF. What will the LCM? LCM will be multiplication of all this. This is the LCM. What is 23 into 1 into 3? It is 69. So in this way, in a fast manner, you can do. Let's understand this for another example. Let's take the example of, let's erase all this. Yeah. Let's say, guys, let's take the example of 20, 40, and 60. We will go with the simultaneous prime factorization. What is the prime number that divides all three of them? 2. 2 upon dividing 20, quotient is 10. 2 when divides 40, quotient is 20. 2 when divides 60, quotient is 30. Again, we will be dividing by 2, so it is 5, 10, 15. Right? 5, 10, 15, what is the common number which divides all of them? Is 5. We'll have 1, 2, 3. So in this case, what will be the HCF? HCF will be nothing but multiplication of these three, the common factors, right? 2, 2, and 5. These are the common factors, right? Since they're dividing all three of them simultaneously. So what will be the HCF? HCF will be multiplication of these three, means 2 into 2 into 5, which is 20. What will be the LCM? LCM will be multiplication of all of this, which means 2 into 2 into 5 into 1 into 2 into 3, which is 20, 40, 120. So LCM is 120, HCF is 20, right? Now comes HCF and LCM of fractions. So we are having two formulas. We also have a question in today's live class related to this. So LCM of fractions means it is LCM of numerator upon HCF of denominator, and HCF of fractions mean it is HCF of numerator and LCM of denominator. Let us say we have taken examples like, say, let's say the fractions are a by b and c by d. So what is the meaning of LCM of fractions? Means LCM of a by b and c by d. LCM a by b comma c by d is equal to LCM of a comma c divided by a and c are the numerators. So LCM of a comma c, and HCF of b comma d. B and d are the denominators. Similarly, HCF a by b and c by d will be what? HCF of numerators, which is HCF a comma c, and LCM of denominators, which means LCM b comma d. Right? This is what we call as LCM and HCF. Fine. Of fractions. Okay. Number of factors. Now comes the next topic, which is number of factors. Let's see what time we're 8:52. We are having sum of factors, number of factors, co-prime numbers. Okay, so 3 more slides we're having. Fine. Number of factors, guys. So number of factors means any number. As I have told, factors, their number can be counted, right? We can count the number of factors, right? Now, how to find what is the formula for number of factors? The formula for number of factors is that any number n, we will write it in its prime factorization form. Let's say the number n can be written in the form p1 to the power a1 times p2 to the power a2 times p3 to the power a3 times p4 to the power a4, and like this the series goes on, right? Where p1, p2, p3, p4, these are the prime factors. They are the prime factors of n, right? They are the prime factors of n. So number of factors of n, so number of factors of n will be what? It is a1 plus 1 multiplied by a2 plus 1 multiplied by a3 plus 1, and this goes on. Okay, this goes on. Let us take an example. Let's take the example of 960. We know 960, we have done the prime factorization. If you have guys forgotten, please go to the previous slide and see. 960 was 2 to the power 6 into 3 into 5. This is the prime factorization of 960. So we are having the prime factors 2, 3 and 5. We also know the powers. 2 to the power 6. Now 3 is only 3, means 3 to the power 1 and 5 to the power 1. So what are the number of factors? Number of factors of 960 will be then what? It is nothing but 6 plus 1 multiplied by 1 plus 1 and multiplied by 1 plus 1, right? A1 here is 6, power of 2 is 6, 6 plus 1. Power of 3 is 1, 1 plus 1. Power of 5 is 1, 1 plus 1. So 6 plus 1 into 1 plus 1 into 1 plus 1 is 7 into 2 into 2, which is 28. So the number of factors of 960 are 28. Right? So this is the way to find number of factors. Just break the number into prime factorization form. Whatever the exponents of the prime numbers you're having, you add 1 to each of them and you multiply all of them, right? Okay. Then we are having sum of factors. Sum of factors is basically, guys, again, we are having 960. We are having 28 factors of it. Now, what is the sum of all 28 factors? What is the sum of all these 28 factors? If someone asks you that what is the sum of all 28 factors, for this also we are having a formula. Again, we will see the general form first. So n equals to p1 to the power a1, p2 to the power a2, p3 to the power a3. Like this, the series goes on, right? Sum of factors is basically sum of factors is given by the formula. Now p1 to the power a1, so I will say it is p1 to the power 0 plus p1 to the power 1 dot 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 up to p1 to the power a1. We will sum all the powers of p1 multiplied by summation of all the powers of p2. Like this, it goes on, right? For example, 960. This we can also write as, this thing we can also write as p1 to the power a1 plus 1 minus 1 divided by p1 minus 1 into p2 to the power a2 plus 1 minus 1 divided by p2 minus 1. Like this, the sum of factors, I mean, this is a general formula. Let's try to do this for the example 960. 960 is 2 to the power 6 into 3 into 5. So what will be sum of factors? SOF, sum of factors will be nothing but 2 to the power 0 plus 2 to the power 1 up to 2 to the power 6. We will add all the powers of 2 and we will multiply this with addition of all powers of 3. Highest power of 3 is 1, so it is 3 to the power 0 plus 3 to the power 1 into, again 5's power is 1, so it is 5 to the power 0 plus 5 to the power 1. This we can also write as 2 to the power 7 minus 1 by 2 minus 1, 3 to the power 2 minus 1 by 3 minus 1, and we are having 5 square minus 1 by 5 minus 1. This is the sum of factors, right? Okay. Now, yeah. So guys, Cracku has launched its WhatsApp channel for this IP MAT exam, for this IIM Bangalore entrance test, right? So basically, guys, the reason to do is, since IIM Bangalore entrance test is being launched for the first time, I mean, we don't know, I mean, we are not having any PYQ, right? We are not having any reference. So all the aspirants have, so we have thought, I mean, our Cracku team has thought that we will form a WhatsApp group so that we can help all the aspirants, since this exam will be conducted for the first time. So you can find the link in the description, right? Do go and join this group, right? We are having a lot of aspirants in this group. Also, we are having the Cracku content team, and also Madhu sir and I mean Siley ma'am, both of them are there. So any doubt related to exam, any queries, anything related to this test, right? I mean, throughout the, anything, say in test you want to know something, right? Or any of your doubt, I mean, you're solving question, the doubt is not getting solved, right? So all these queries and everything you can ask in this group, right? So please, the link is in the description. Please click in the link and join the group, right? It is a very good, community. We are having a lot of members. So if you join, you will get not only good guidance, but also you can get a nice peer group, right? So guys, please search the link. I mean, it is just in the description. Go and click it and join the group, right? Chalo. Then we are having co-prime numbers. Now, what are co-prime numbers? The simple definition of co-prime numbers means their HCF will be 1. What is the meaning? If their HCF is 1 means there is no common factor of the numbers other than 1. For example, let's take the example of 16 and 9. Now 9 and 16, these are not prime numbers, right? 9 is 3 square, 16 is 2 to the power 4. So 9 and 16 are not prime numbers, but 9 is 3 square, 16 is 2 to the power 4. So I can say there is no factor common to 9 and 16 other than 1. There is no factor common to 9 and 16 other than 1. Other than 1, no factor is common. So from here also I can say that the highest common factor of 9 and 16 is 1. The highest common factor of 9 and 16 is 1. So the highest common factor of two numbers or three numbers or any number, if it is 1, that which means there is no other factor or there is no other number which divides both 9 and 16, right? That is the meaning of factor. Factor means which will divide this number. So if there is no number which divides 9 and 16 or divides a set of numbers other than 1, we will tell that set to be co-prime. So I can tell 9 and 16 are co-prime to each other. What I will call? I will call 9 and 16 are co-prime to each other. Right, guys? So HCF is 1, right? Our condition is HCF is 1, which means only one will be, only the numbers will be divisible by 1. There is no other number, no other common number which will divide them. So that we will call co-prime number, which means simply HCF is 1. Let's move to, the first question of the day. Let's start the timer. Think timer is on or not? No, why the timer is, yeah, timer. Yeah, 2 minutes, guys. Try to solve this question. Okay, we are 9-3. Okay, let's see how many questions we can solve. Oh, the 42 seconds are left. Fourteen seconds left. Okay. So this is not an easy question, to be honest, but okay. We are starting with a tough question. Okay. So Mr. Naseeb is telling it looks like a tough question. Yeah, it is a tough question, not an easy one. कोई बात नहीं. Sorry sir, I joined late. It's fine. No issues. Sandeep, it's all good. Okay. Let's understand. Now this is tricky question, right? This is not an easy question, I will say. This is tricky. Let's see. Number of positive integers which divides 1890 multiplied by 130 multiplied by 170 and it is not divisible by 45. By the way, guys, one thing to tell. This is a previous year IP MAT Indore question. I think it was IP MAT Indore 2020. I'm not sure of the year, but this is a previous year IP MAT Indore question, right? So this is a previous year question. So in exam, questions like this can come, but no worries, Cracku is there to help you, right? For questions like this only, we are there, right? So no worries. Let's understand the question. Number of positive integers which divide 1890 into 130 into 170. So we are having a number, fine. But, and which are not divisible by 45. Which are not divisible by 45. First, let's understand the first part of the question. First part is what is it is telling number of positive integers which divide this. What we have learned, numbers which divide our number n. The numbers which divide our number n, what we call them? We call them factors, right? The numbers which divide a number n, we call them factors. So basically the question is telling factors of this. We need to find the factors of it and we need to find what? Number. Which means we need to find the number of factors. Our main agenda has to be to find the number of factors of this. And how to find the number of factors? If you guys recall, the way to find number of factors is simply break the number in the prime factorization format, simply break in this format and we will apply this formula. This is the simple thing. So let's break this number into prime factorization format. Yeah. So we are having 1890 times 130 times 170. 1890 I can write as 189 into 10 into 130 I can write as 13 into 10. 170, second, yeah, 170 I can write as 17 into 10. So, and 189 is what? 189 is, guys, it is 3 into 63. We are having 1, 2, 3 times 10 we are having. 10 cube. And we are having 13 into 17. Now, 3 is a prime number. What is our main goal? Our main goal is to write in the prime factorization format, right? That is our main goal. Now, guys, understand 13, 17 and 3. These are prime numbers. But 63 and 10, these are not prime numbers. So, we need to further break 63 and 10 into the prime number format. 63. Let's observe this. 63 is what? 63 is 9, 7. 9 into 7. What is 9? Now 7 is a prime number. 9 is not a prime number. So 9 I can write as 3 square into 7. Right? 9 is 3 square. So basically 63, I can write this in the prime factorization format as this. 3 square into 7. So we will replace 63 with this. Why are we replacing? Because we need to find prime factorization format for this number. We can't use 63 because 63 is not a prime number. We need to write 63 in its prime factorization format. So we are writing it here. We are having 13. We are having 17. These are good numbers, right? They are prime numbers already. 10. 10 is what? 10 is 2 into 5. So instead of writing 10 cube, right? I mean the prime factors of 10 are 2 and 5. So instead of writing 10 cube, I can write as 2 into 5 cube. Let's see this. So guys, here you go. 2 cube into 3 square into 3 means 3 cube into 5 cube into 7 into 13 into 17. This is the complete prime factorization format or the complete prime factorization of this number. So we have got it in its prime factorization format. So what is the formula for number of factors? The formula for number of factors, what was it, guys? It was nothing but whatever the powers of the prime factor we are having, add 1 to each and every power and multiply all of them. Now power of 2 is 3. So it is 3 plus 1. Power of 3 is 3. 3 plus 1. Power of 5 is 3. 3 plus 1. Power of 7 is 1, 13 is 1, 17 is 1. So here it will be 1 plus 1. Just add 1 and keep on multiplying. Again 1 plus 1. This one is of 13. And for 17 also we'll have 1. So it is 1 plus 1. So basically 4 into 4 into 4 into 2 into 2 into 2. So basically we will have 4 multiplied 3 times, this is 64. 2 multiplied 3 times is 8. So it is 64 into 8, which is 512. Okay. So we have got 512, the number of factors of this number. This number, the number of factors are 512. Which means I can tell the first part, number of positive integers which divide this. So how many positive integers are dividing this? Answer is 512. Okay. First part is solved. But the question is asking, it is not divisible by 45. Let's understand this. Now, if you guys see, we are having 512 factors of this number. There will be some numbers, some factors. There will be some factors which will be divisible by 45, right? Since the question is telling which are not divisible by 45. Means among these 512 factors, which factors are not divisible by 45? Means there will be some numbers or some factors which will be divisible by 45, and we need to subtract it from this, right? I hope you guys are getting the idea of the question. Question is telling we have got answer of the first part, that 512 integers are there or 512 factors are there of this big number. Question is telling we have to eliminate the numbers which are divisible by 45. Means among these 512 factors, there will be some factors which are divisible by 45. So we need to eliminate them. How to do this? Very simple. We will again use the prime factorization format. What is 45, guys? 45 is 9 into 5. What is 9? 9 is 3 square into 5. 9 is 3 square into 5, which means this prime factorization format. Can I write it like this? 3 square into 5. Under bracket I will write 2 cube. Now I have taken 3 square common, so inside it will be 3. Then I have taken 5 as common, so inside it will be 5 square. Then it is 7. Then it is 13. Then it is 17, right? So I can write, this is the prime factorization, I can write as 45 multiplied by something. Now, if I find number of factors of this, understand this, guys. If I find number of factors of this, can I say the number of factors, whatever number we are getting, they will be divisible by 45? Since we have taken already 45 common, so I can tell whatever the number of factors we get, they will be divisible by 45 for sure. Now, what is the number of factors of this? Again, same process. Powers we know, we will add 1 to each and every power and we'll multiply all of them. So it is 2 cube. So power is 3, 3 plus 1. 3 to the power 1. Power is 1 plus 1. 5 square. 2 plus 1. 7 to the power 1. 1 plus 1. 13 to the power 1. 1 plus 1. 17 to the power 1. 1 plus 1. So this is 4 into 2 into 3 into 2 into 2 into 2. What is this? 8, 24, 24 into, so this is 24. This is 8. So 24 8 is 192. Right? Which means I can tell that the number of factors which is divisible by 45 is nothing but 192. Right? This thing we have derived from here. This big number we have converted into prime factorization. We have used this prime factorization to find factors which will be divisible by 45, and we are getting 192 as the answer, which means guys, among these 512 numbers, 192 numbers are there which is divisible by 45. Among these 512 factors, we know 192 numbers are there which is divisible by 45. So what is the final answer? Final answer should be 512 minus 192. The reason being, we have to find which are not divisible. Means we have to eliminate the cases where the number is getting divisible by 45. So it is 512 minus 192 and answer is 320. It was a theta question. So basically you have to type in the answer and the answer is 320. If you guys have not understood the solution, I will request you guys to please see the recording of this, right? I mean, after the after this live ends, after this live stream ends, you will get in YouTube only the video recording. Please understand, because this is a very conceptual question, to be honest, right? This is not an easy question. The reason I have taken this question is so that I can make you guys understand that, even if the questions look tough and all, we can solve the question in our main method. What is our main method? Our main method is prime factorization method, right? If we are good with this, then we can solve any problem. I hope it is okay. Let's move to the next question. Okay, this is again not an easy but not too hard. Okay, we are having 44 seconds more. Again, guys, try to think in the line perfect squares, right? Mm. 8 seconds more to go. Yeah, time up. Now, guys, let's understand this. Number of factors of this which are perfect squares. Now, understand, if the question was up to this, if the question was number of factors of this, it would be a very easy question, right? Simply what we have to do, we would have done 3 to the power 5, 5 to the power 8 and 7 square. Already it is given in the prime factorization format, right? So only thing we need to apply the formula. What is the formula to find number of factors? Add 1 to each and every power of the prime number and multiply them. Means 5, add 1, 8, add 1, 2, add 1 and multiply. So it is 6 into 9 into 3. So it is 54 into 3, it is 162. Right? A very simple question, life would have been easy, right? But what is the thing? Perfect squares. Now among these 162 factors, right? These are number of factors. Among these 162 factors, we have to find those which are perfect square. So here the complexity comes. That how many numbers among these 162 factors will be perfect squares? Again, no tension. Cracku is here to help you, right? I am here to help you. Let's see. First of all, let's understand perfect squares. What is perfect square? Perfect square means a number perfect square means it can be written in the format say p square. Means the power has to be, it can be written in power of 2. P square, right? I hope you guys are getting it. If it can be written any integer, if it can be written something to the power 2, it is a perfect square. Now, if it is something to the power 2, I can say if it is something to the power 4, then also it will be perfect square. Reason being, say this is x to the power 4, I can write this as x square square. Means again, I can write this as something to the power 2. So basically, perfect square means if the number can be written something to the power even, means whether this is 2, 4, 6, 8, if it is even, then I can say that number is perfect square. We will use the same concept over here. See guys, 3 to the power 5. What are the powers of 3 which is present in this number? The powers of 3 which is present is 3 to the power 0, 3 to the power 1, 3 square, 3 cube, 3 to the power 4 and 3 to the power 5. Similarly, 5 to the power 8. What are the powers of 5 present in this number? 5 to the power 0, 5 to the power 1, 5 square, 5 cube, 5 to the power 4, 5, 6, 7 and 8, right? We can't get a power greater than 8 for 5 because highest power is 8. And what are the powers of 7 present in this number? It is 7 to the power 0, 7 to the power 1, 7 square. Now, understand, for the number to be a perfect square, what we have learned that this power should be even. We need to consider only the even powers. Let's understand, let's try to find out the even powers. What are the even powers of 3? 3 to the power 0, 3 square and 3 to the power 4, right? These are only the even powers. Rest all 3 to the power 1, 3 cube, 3 to the power 5. These are odd powers, means they can't be expressed in the perfect square format, right? 3 cube, you can't express them in perfect square format, but 3 to the power 4, it is 81, you can write as 9 square. So 3 to the power 4 being an even power, you can write it in the perfect square format. Similarly for 5, what are the perfect squares? 5 to the power 0, 5 square, 5 to the power 4, 5 to the power 6, 5 to the power 8. These are the perfect squares. And for 7, what are the perfect squares? 7 to the power 0 and 7 square. Now, what is the first thing? First thing is, the number has to be a factor. If it has to be a factor, means it should include 3, 5, 7 for sure, right? It should include powers of 3, 5 and 7 for sure, right? And it has to be a perfect square, means we will only deal with the perfect squares. We will only deal with things which are perfect squares. This and this. So from 3, how many powers we can choose? We can choose 3 powers. What are those 3? 3 to the power 0, 3 square and 3 to the power 4. From 5, how many powers we can choose? We can choose 1, 2, 3, 4, 5. From 5, we can choose 5 powers. From 7, we can choose how many perfect squares? We can choose 2. So basically, the number of factors which are perfect squares, it will be what? 3 into 5 into 2. Reason being, for that number to be a factor, it should include powers of 3, 5 and 7. Now, how many powers of 3 are perfect square? There are 3 powers which we have written, they are perfect square. How many powers of 5 are perfect squares? There are 5 powers which are perfect square. How many powers of 7 are perfect square? There are 2 powers which are perfect square. Now for the factor to be, for the number to be a factor of this, it should include powers of 3, 5 and 7. And also it is to be perfect square, means it should include powers which are perfect squares. And how many such possible numbers can be there? 3 into 5 into 2, it is 30, which means our answer is 30. Again, our theta question means you have to type in the answer, not an MCQ. So what is all learning from here? Total factors are 162, but in this 162, only 30 factors are there, which is a perfect square. Right? This is a learning from the question. Again, a very conceptual question. Again, you have got a new way to think, a new kind of problem. And again, we have used only our old method, that is prime factorization method. Nothing else, nothing fancy, nothing rocket science, just the very basic prime factorization method that we have used. Let's move to the next question. This is a very easy question, guys, and I hope most of you will get it right, because of formula we have discussed in our previous slide only. Okay, 41 seconds, guys. Just use the formula, right? Just use the formula which we have read, right? HCF of fractions, LCM of fractions. Question is about HCF of fractions, and you can easily solve it. Six, five, four, three, two, one. Okay, timer. Let's see. What are the fractions given? Fractions given are 2 by 3, 4 by 6, 8 by 27. We know HCF of fractions. What is the formula? The formula is that it is HCF of the numerators and it is a LCM of the denominators. LCM of denominators. This is a formula which we have read in the previous slides, right guys? HCF and LCM of fraction. Now, the thing is there, most of the people will use this formula, right? And obviously I will also use this formula, but most of them will get the wrong answer. I mean, what people will do, we are having 2 by 3, 4 by 6, 8 by 27. What people will do, they will do HCF of 2, 4, 8. They will do LCM of 3, 6, 27. Now HCF of 2, 4, 8 is what? It is 2. LCM of 3, 6, 27 is what? It is 54. And they will get the answer 1 by 27. No option is 1 by 27 and they won't be able to mark the answer. So where did we went wrong? Where did we went wrong that this formula is not giving us the answer? Always remember guys, when we will apply this formula, always remember all the fractions need to be in the reduced form. Reduced form, I mean simplest form. If you see 4 by 6, this is the black sheep. 4 by 6 is not in its simplest form. We can simplify this. So basically the question is, we need to find HCF of 2 by 3, comma 2 by 3, comma 8 by 27. A very important learning while using this formula and also the LCM of fractions. Whatever formula we will use the formula only when all our fractions are in the reduced form. Reduced form in the simplest form. By simplest form means we can't cancel the numerator and denominator by a common number, right? I mean, we can't simplify it anymore. Now we can apply the formula. So basically HCF of 2 by 3, 2 by 3 and 8 by 27 is what? It will be HCF of 2 to 8, LCM of 3, 327. What is the HCF of 2 to 8? What is the highest common factor? It is 2. What is the least common multiple? It is 27. Right? 3, 3, 27. The LCM will be 27. HCF of 2 to 8 will be 8. So basically our answer is 2 by 27. So the correct answer is option A, 2 by 27. Again, an important learning, guys. Chalo, let's move to the next question. Okay, let's start the timer. Okay, guys, so time is up. I hope a lot of you guys would have been able to solve this question. I am optimistic about my teaching, right? Yeah, let's open the chat. Okay. Okay. LCM of two numbers is 12 times their HCF. Sum of LCM and HCF is 403. One number is 93. Find the other number. Okay. Okay. I think this part, LCM of two numbers is 12 times their HCF. Suppose. Acha, again, one more thing to say, this is also a previous year IIMB question. These questions are previous year questions, right? So these kind of questions can be asked in the IIM Bangalore test also. HCF, let's say HCF be X. So from here what I can write? LCM will be 12 times their HCF, which means LCM will be 12x. So sum of LCM and HCF. So sum of LCM and HCF will be what? X plus 12x, which is 13x. Now this sum is equal to 403, which means 13x is equal to 403. So from here I can find the value of x, which is 403 by 13, which is 31. So basically I have got HCF as 31 and LCM I am having as 12 into 31. Okay. Now, what is being given? It is given that one number is 93. Now 93 is what, guys? 93 is 3 into 31. Now one number is 93. We need to find the other number. Now HCF is 31. Means can I write the numbers as 31A and 31B? Right? Can I write the numbers as 31A and 31B? Because the highest common factor is 31, which means 31A and 31B. But the thing we need to note is that A and B has to be co-prime. Now, why A and B has to be co-prime? Let's understand this, guys, because this thinking we will use in another question. So let's understand here only. Let's say 31A. Let's say the value of A be 2, B be 3. So it is 31 into 2. It is 31 into 3. Right? So one number is 31 into 2. Another number is 31 into 3. What is the highest common factor? Simply 31. Highest common factor is 31. But let's say A equals to 2, B equals to 4. In this case, what will be the number? 31 into 2 and 31 into 4. Now 31 into 4. Now 4 is not a prime number, right? 4 we can still break. So 4 is 31 into 2 square. Or I can write 31 into 2 into 2. And here I am having 31 into 2. In this case, what will be the HCF? In this case, HCF will be 31 into 2. Or I can say, in this case, HCF is changing. So for the HCF to remain 31, A and B has to be co-prime to each other, right? 2 and 3 are co-prime to each other. 2 and 4 are not co-prime to each other, right? 2 and 4 co-prime to each other means co-prime number means whose HCF is 1. I mean A and B, there are no common factors. Since there are no common factors between A and B, so the highest common factor between 31A and 31B will be 31AB. Okay. Now 31 and 31B we are having. HCF we have got as 31. Now we have a rule. That rule is product of two numbers is equals to HCF into LCM. So two numbers product is equal to their HCF into LCM. Now HCF is 31. Numbers are 31 and 31B. So 31A into 31B. This is my product of two numbers. HCF is 31 multiplied by LCM. 31, 31 I can cancel. So what is the LCM? LCM is 31AB. And LCM is what? 12 into 31 in this case. Means this we can equate to 12 into 31. So AB equals to 12. So LCM from here I can see AB equals to 12. Now A is what? The value of A is 3 because one of the numbers is what? 93. 31 into 3, one of the numbers. Value of A is 3. So if I put A equals to 3, I will get B equals to 12 by 3, which is 4. Which means the value of B is 4. So what is the other number? Other number is 31B, which is 31 into 4, which is 124. So guys, from here I can say that the other number is what? 124. So again, a new approach to solve this question, right? The first part was simple. We had found the HCF, we have found the LCM. Up to this, the question was simple. But the trick comes when we have to find the other number and one number is given. So the approach for this kind of question is that HCF we have found out 31. We will just assume the numbers to be 31A and 31B such that A and B are co-prime to each other. Once A and B are co-prime to each other, we will find the LCM, which we have got a 31AB. This we will equate to the main LCM, 12 into 31. We found AB, right? A is given as 3, right? 93, 3 into 31. So A I can take as 3. From here I found out B, which is 4. So the other number will be 31B, which is 31 4s are 124. Right guys? If you guys have not understood the solution, shit, why is this not moving up? Okay. If you guys have not understood the solution, please go and watch the recording, which you will get after the live stream ends, and please, rewatch it. Let's move to the next question. Okay. Yeah, this was the question I was talking about when, where we will see the divisibility test of 7. Okay. So I think this will be the last question of the day. Okay, guys. Now, let's understand. Placing which of, again, this is a previous year IBMAT question. Now, since this question has come in IIM Indore's IPMAT, there is a chance that this kind of question can come in the IIM Bangalore UG test. Let's read. Placing which of the following two digits at the right end? Right end means 4530. So this is the right end, right, left. At the right end of 4530 makes the resultant 6-digit numbers. We are already having 4 digits. So we need to add 2 more digits. Resultant 6-digit number divisible by 6, 7 and 9. Okay. Let's understand. Divisible by 6 means what? Divisible by 2 and 3. Divisible by 9 means what? It would be divisible, sum of digits will be divisible by 9 and divisible by 7. The rule for divisibility test of 7, which I will tell now. First of all, let's use these two, divisible by 6 and 9. 4530. Now, 4530, what is the, let's take this, 96. Okay, 4530. What is the sum of digits till now? Sum of digits is, till now sum of digits is 4 plus 5 plus 3 plus 0. Which means 4, 5, 9, 9 plus 3, 12. What are the numbers? The numbers, possible numbers are 96, 78, 42 and 54. 96. In 96, what is the sum of digits? 9 plus 6, 15. 7 plus 8, what is the sum of digits? 7 plus 8, 15. 42, what are the sum of digits? 4 plus 2, 6. And we are having 54. 54, what are the sum of digits? It is 9. Now, already we are having sum of digits are 12. Already we are having sum of digits as 12. But after after adding two numbers, two digits, after adding two digits, the overall sum of digits of the whole of this digit number, the overall sum of digit will change. In the first case, in the case of 96, what will be the overall sum of digit? It will be 12 plus 15, which is 27. In the case of 78, right, this is 453096, this is 453078, this is 453042, and this is 453054. So in this case, the sum of digit will be again 27, right? Already we are having 12, add 15. Already we are having 12, add 6, 18. Already we are having 12, add 9, 21. Now, 27, 27, 18 and 21. All the numbers are divisible by 3. All the sum of digits are divisible by 3. And all of them are even numbers, right? 6, 8, 2, 4. Which means all the numbers are divisible by 6. All numbers are divisible by 6. For 9, what should be the condition for 9? The sum of digits has to be divisible by 9. Now 27 is divisible by 9, 27 is divisible by 9, 18 is divisible by 9, 21 is not divisible by 9, which means our fourth option will be obviously out, which means after finding numbers divisible by 6 and 9, we are still remaining with 3 options. Out of these 3 options, we will have one option in which sum of digits, in which that number will be divisible by 7. Now the divisibility test of 7, let's understand this, guys. The divisibility test of 7 goes like this: 453096. You make pairs of 2 from the right hand side, means this will be a pair, this will be a pair, this will be a pair. From the right hand side, I will make the pair of 2. I will multiply each pair with the power of 2 such that the first is 2 to the power 0. Here the power will be 2 to the power 1. Here the power will be 2 square. Right? Yeah. Upon multiplying this, add all of them, which means 45 into 2 square plus 30 into 2 to the power 1 plus 96 into 2 to the power 0. But I will get 45 into 2 square means 45 into 4 plus 30 into 2 plus 96 into 1. 45 into 4 is 180, 30 into 2 is 60, this is 96. So 180 plus 60 is 240, 240 plus 96 is 336. Now is this number, after doing this multiplication, after making the pairs, multiplying with powers of 2, is this number divisible by 7? 336, yes, 336 is divisible by 7. 336 is 48 into 7. Which means this number will also be divisible by 7. Which means our answer would be option A, 96. Let's do this again for another number. Let's do this for 453078. Again the same logic, make pairs of 2. Right, now this number won't be divisible by 7. Let's see that. Multiply with 2 to the power 0, multiply 2 to the power 1, multiply with 2 square. So 2 square into 45 will give me 180. 2 to the power 1 into 30 will give me 60. 2 to the power 0 into 78 will give me 78. Adding all of them, we will have 180 plus 60, 240. 240 plus 78 is 318. 318 is not divisible by 7. The reason being we have 7 into 45 as 315. So the next number would be 322. 318 is not divisible by 7, which means this number is not divisible by 7. So in this way, you can do the divisibility test of 7 and the answer we got is 96. Okay, it is 9:53. So guys, for today, let's end the session, right? I hope you guys have learned a lot of things. I mean, a lot of things regarding the basics of number. uh, Recap of today's session. So today we have learned about prime, what are prime numbers. We have learned how to find or how to convert a number into its prime factorization method. After that, we read the concepts of factors and multiples. Following that, we read HCF and LCM. Following that, we read how to find number of factors, how to find sum of factors, and also we read the divisibility test of the prime numbers, right? After that, we have solved 5 questions. 5 questions, all the 5 questions are from previous year IPMAT papers. Now, since they're coming in IPMAT, they might come in IIM Bangalore UG test, right? Because both exams are conducted by IIMs. IPMAT is by IIM Indore and Rohtak, and this is by IIM Bangalore. So there is a possibility that questions of this kind can come. All the questions had their unique way to solve, had a unique thought to solve, had a unique concept. All of them we have discussed very well. I think if any of you guys have any problem, do ask the doubt in to the Cracku doubt team. I will solve your doubt. Also, I will request all of you to rewatch this lecture from the start, and especially while solving the questions, the methods which I have shown. It might happen that you might not grasp the method in one go. So rewatch this lecture. Also, share this lecture to all your friends, right? Or if, or anyone you know who is preparing for this test, because Cracku as a team is putting a lot of effort for this exam. So to help you guys who are preparing for the test, we are providing free lectures, free mocks, right? So because we want you guys to get into IIM Bangalore UG program, their first batch, right? That is our dream. So please guys, share this lecture. Also join the WhatsApp community, which link you will get in the description, right? And that is a very nice group. You can get a peer group to study, right? You can get your doubts solved. Yeah guys, so this is for today, and good night. Bye bye. वो